This video is going to cover LibAuth, which is a tool for creating custom Bitcoin Cash transactions, particularly for people who want to develop in Bitcoin script, which is the very, very low-level assembly language used to create custom Bitcoin transactions. Now, this video is not going to get into script. It's going to introduce LibAuth and the tooling around LibAuth in order to generate a pay-to-pub key hash, this P2PKH transaction. This is the most common type of transaction on the network, and it's a good one to start with because just about every Bitcoin tool out there can generate these transactions. So it's a great benchmark for comparing these different types of tools. And I haven't seen a video quite like this introducing LibAuth and how to use it to generate a transaction, which is a basic stepping stone for creating custom transactions. So here's the high-level goals of this video, or someone who would maybe watch this video as a stepping stone to learning Bitcoin script. And what this essentially lets you do is build business solutions. For me particularly, I'm working up to this escrow script, which is used so that a buyer can put money into escrow. That way the seller's there, and if there's a dispute, a third party can resolve it by determining who gets the money. And this escrow is a great business solution for solving what I call the trust problem. It's like this chicken and egg problem of how do you start a trade when neither party trusts one another. Well, escrow is a solution to that. So I'm not going to cover that in this video, but that's ultimately where I personally am trying to get. And so studying this pay-to-pub key hash example was my stepping stone to there. And before I go any further, I really want to thank Sam Rock, who did most of the heavy lifting and put all this code together, and Jason Dresner, who created LibAuth and helped me get over a few of the hurdles. Without standing on the shoulders of those particular giants, I would not have been able to make this video or make the progress that I've made. So this video is really just an attempt for me to pay it forward and share this knowledge with more people. So the focus of this video is really just to understand the tooling. I'm going to assume that the reader is familiar with locking scripts and unlocking scripts, and if you are not, then I suggest that you Google Mastering Bitcoin GitHub. It's Andreas Antonopoulos' book, which is available for free on GitHub at this URL. And you can scroll down here and read through these chapters. This is where anybody should start when it comes to learning Bitcoin. This video is going to focus more on driving the car, whereas this book focuses more on how internal combustion engines work, to use an analogy. So I'm not going to get into those kinds of nitty-gritty details. That's all here. And then as a follow-up reading, users can go to fullstack.cash. There's a button halfway down that says documentation, or you can just type in fullstack.cash/documentation. Click on Mastering Bitcoin Cash. And so we have our own copy of Andreas's book, customized for Bitcoin Cash. And this was written, or customized, I should say, by Gabriel Cardona. So these are a couple great references for learning the technical details. Again, I'm just going to focus on the tooling and assume that the watcher can learn that information. So LibAuth has a couple different tools. The place to start is going to ide.bitauth.com, and this is a tool that can be used to generate a template, and using the template makes it a lot easier to work with Bitcoin script. So when you go to ide.bitauth.com, you'll see this window, and it'll ask you to choose a template. We're going to use this simplest one, the single signature pay-to-pub key hash transaction. And another thing I strongly recommend before you get going too deep is click this button on the guide and read through this. This explains how these templates work, particularly the entities, scripts, and scenarios. Everything kind of revolves around those three concepts. So definitely read this. And I'm actually going to leave this unchanged. Actually, the one change I did make is I switched it from HD key to key because I just want to use these WIF private keys. I don't want to deal with an HD wallet right now. So that was the one change I made, and then I was able to go up to this gear and export the template into a JSON file, and you can download template and that is this file here. This is the template. So it's just a JSON file, or and I converted it to a JavaScript file by putting that information into a variable, and it just describes how this pay to pub key hash transaction works. This is the locking script, and this is the unlocking script. And thankfully, because this is a template, we don't need to get too deep into the weeds there. So if you want to follow the code that I'm going to show today, I have a GitHub repository on github.com/Chris Troutner, and the repo is called escrow script. And I'm going to focus on this pay to pub key hash spend script program. So I've got that here, and I'm going to walk through this code. That's what I'm going to do for the rest of the video, and then I'm going to execute it. I'm going to show you how you can run it and customize it for your own needs so that you can study it at a deeper level. And again, this is all in an effort as a stepping stone to get to more sophisticated, customized Bitcoin transactions. So I just showed how to generate script templates and then how to export them, and then all I did to convert it from JSON to a JavaScript file is I assigned the JSON to a variable, and then I exported it, and that allows me to then import it into my program. Okay, so pay to pub key hash, it's most common transaction, good stepping stone. Okay, I need to customize the UTXO, and then I will walk through the code and then broadcast the transaction. So libauth is, let me actually pull up the package.json file. So libauth is the primary library that's letting us do all this, and these are the functions that I imported from that library. And so here is my JavaScript dependencies. I've got the libauth, and it's important to use this version, not the default version, which is version 1. We're using version 2, which is still in an alpha release. So it's critical that you use this version. And then I also added minimal SLP wallet. This just simply lets us broadcast the transaction at the end. libauth does not have a connection to like a full node, which you need in order to broadcast the transaction, but minimal SLP wallet does. And then standard is simply for formatting, for keeping the code looking good. And this should be MIT. And so let me walk through this code. There's the global NPM dependencies up here, so libauth and all the functions we're importing from it. Then minimal SLP wallet, which will let us broadcast the transaction. And then here's that template that I showed. And so those are all my dependencies. And then in order to customize this transaction, I have some constants here. So I'm starting with a with private key, and here is the Bitcoin Cash address that corresponds to it. So let's check that out right now and see what UTXOs it has. To do that, I'm going to go to fullstack.cash/explore-bchn. And under Electrum X, I can go to get UTXOs. I'm going to get all the UTXOs associated with this address. Okay, so it has no UTXOs. There's no balances in this address. So we need a UTXO to spend. So I'm going to go to my wallet here at wallet.fullstack.cash, and I can toggle this button right here to switch between Bitcoin Cash and US dollar denomination. So I'm going to paste in that address, and I'm going to send it 10,000 Satoshis, so which is 0.0001 Bitcoin Cash. Okay, so that's been broadcast. And now if we go back here to the Explorer, we can query the ElectrumX network, and we can see that now we have a UTXO of 10,000 Satoshis at an output of 0, and it block height 0 because it hasn't been confirmed yet, but that's okay. We can work with 0conf. And we need that transaction ID. And so with that information, I can customize this UTXO by swapping out that transaction ID. That's what I just got from here. And I've been working with $10,000 or 10,000 Satoshi UTXO, so that's why that number's here. If you send a different amount, you'll need to make sure that this number and this number match, as well as the 0 and the 0. These are 3 critical pieces of information, and the transaction won't work if any of these are not accurate. So we've got the private key. This is the private key that controls this UTXO, and we're going to send it back to that web wallet that I just showed. So these are the 3 variables that you need to customize for your transaction. Everything else is boilerplate, but I'm going to walk through it just to help understand what each of these calls are. These are all coming from libauth, and unfortunately there's not a great deal of documentation. That's why it was so difficult for me to learn this. I had to basically pick the brain of Jason and Sam, and then this is the reference, but I believe this is for V1, so some of the functions are in here and some of them aren't, if you want to get more information. But the structure of a transaction is always the same, regardless of what tool you use. So if you use BCH.js to create a transaction, this structure is going to be roughly the same, even though you're going to have different function calls. So I'll just walk through this, and then we'll run the program and generate the transaction and look at it. So to start with, it decodes that WIF. So it's taking this WIF encoded private key and turning it into a binary object that libauth can work with. And then I'm importing that template. That's this JSON template that was generated by the IDE. And I think one change I had to make was, where was it? Well, it's called key. Name is key and type is key. And so I had to, right here, I had to make sure that I use key here. I guess that's not as confusing for you as it was for me. So basically we're importing the template, and then we're compiling the template with this function here. So basically compiling it into binary bytecode, or at least we're instantiating the compiler. That's what we're doing with this step, is we're instantiating the compiler with the template. And then in this step, we're generating the bytecode, so an actual part of the transaction. And this is where it's critical to have this correct. Everything else is boilerplate, but we're providing, if you uncomment this, you can see that this object owner has a private key property. And so we're just essentially plugging in the private key for the owner into this template at this point. And this will print out the address that we're going to send the Bitcoin Cash to if it's successful, and if it's an error, then it will throw the error. That's from instantiating or compiling the bytecode. It'll either succeed or fail. And if it succeeds, what we'll get out of it is the address that we're going to send the Bitcoin Cash to. And there's this really handy function here that you can give it a Bitcoin Cash address, or locking, that's further down. That's this one. It's locking bytecode to cache address. So we're taking the bytecode from this object, converting it to an address, and then displaying that address. And then this is the opposite function, where we take the address of the receiver and convert that into bytecode for the output script. So this is the locking script, and this is the unlocking script, or output and input. And then it works with big integers, so we convert the amount of satoshis in that UTXO into a big int. And so we generate an input and an output. We're not going to have any change in this transaction. It's as simple as possible. We're sending the whole amount. So we just have one input and one output. So for the output, we are able to add that bytecode, and then we reduce the amount by 250 satoshis. I should change that. For a mining fee that's the transaction fee that goes to the miner, and so the amount that the receiver will get will be 10,000 sats minus 250. And then we need to create the input side of the transaction, and here's the unlocking bytecode. So we feed it in the data from the compiler object, and then we point to the private key that's being used. This is the big int for the 10,000 minus 400. It's an unlocking script. This is the output index of the UTXO, the transaction ID of the UTXO, and then this number, I'm not exactly sure what it does. It seems to be able to be different numbers. So, but 0 seems to work just fine. And then we compile the transaction. So we generate a transaction with the one input, that's why it's an array, and the one output, lock time 0, which means we can spend it immediately, and it's a version 2 transaction. Again, this is all boilerplate. You don't need to worry about that. It's really just the constants at the top that you have to customize. So then finally, we take that transaction and we convert it into a hexadecimal representation. This is the form that we can give to a full node to then broadcast to the to the network. And if there's an error, it'll throw the error. Otherwise, if it's a success, it'll display the hex on the screen. And then finally, at the end, we instantiate Minimal SLP Wallet. We're using this consumer API interface, which uses the Web3 infrastructure, which is free, and we wait for the wallet to initialize, and then we broadcast the transaction to the Bitcoin Cash network. So let's give this a try. We've already created our UTXO, and so it should simply be a matter of running the script. And so there's the script. Let's run it. So you can see here it generated the Bitcoin Cash address, and that came from this section right here. So it generated the Bitcoin Cash address. Oh, okay, good. We ran into a problem. And then it was able to successfully generate a hexadecimal transaction, and that's what's displayed here. So I could put this I could destructure that if I wanted to debug it. Let's see, missing inputs. So I don't think it likes our UTXO. There must be some problem with the UTXO. So let's look here. Got that. TX position is 0, and the amount of sats is 10,000. Let's check it again. Okay, so it's been confirmed in a block. And okay, let's try it one more time. Missing inputs. There we go. It was successful that time. I'm not sure what happened that first time. But now that we have a transaction ID, we can go to a block explorer. And put in this transaction ID. And we can see our transaction. So we see that, like I said, there's just one input and one output, no change. This is the simplest Bitcoin transaction that's possible to create. there's 250 sats missing on the output that went to the miner, and so what that ended up being a little bit more than 1 sat per byte. And yeah, so that's a transaction. We sent the money back to the web wallet that I funded it with. And so to do this again, I would just send another 10,000 sats to this address, and which is this address corresponding to this WIF. And I would update the transaction ID here. So if you want to run it yourself, that's how you can run this script. Just send 10,000 sats to this address, update this transaction ID, and then run it. And feel free to change anything here. That's what it's here for. But my goal was really to make this as simple as possible, because once you have a frame of reference of things working, then you can take the next step to customize it, make more complex scripts. And if it doesn't work, you can always retreat back to your known good state, which is this script. So from here, that's what I'm going to do. I'm going to start exploring this potential escrow script that I want to develop, and I will make more videos as I do that.